Right, we're ready to go. Question 5. This was the one I relegated to last position because it looked like the hardest to me. Having seen the other 4 questions, at least 3 of the other 4 questions, I'm thinking if this is the hardest one, I'm going to be in for some difficulty here. But let's see how it goes. The A-frame ladder. So at the localised strength, one of the light bulbs has failed and must be replaced. The lightweight ladder is placed on frictionless ice so that it is directly under the light bulb, and an electrician climbs the ladder to reach the bulb. Now it looks like that. There's the bulb where he's trying to get to. Nice. So there's no friction, which means there's no forces on those joins there. For the initial position of the ladder and electrician shown in the diagram, which is that and that, the electrician will not be able to reach the light bulb. Explain. Okay, so crudely one might think, well, he just goes up there and he reaches the light bulb. We're on ice here, so there's nothing stopping that ladder from slipping sideways. And so basically, as we go, the ladder is going to slip. So frictionless ice. So there is nothing to stop ladder moving sideways. Now, with something like this, we can treat, because there's no forces between the ladder and the ice, we can treat the person and the ladder as a system. We can kind of put a closed box, an imaginary box around there. So person plus ladder is a system on which no external forces act. Actually, that's not quite true, because obviously there's a reaction of gravity holding it up, but that's going to be balanced by the gravitational force of the person there. Basically what I'm saying is that the momentum is conserved, so, or at least the momentum horizontally is conserved because there are no horizontal forces on the ladder or the man, because he's on ice. I mean, sure, yeah, the man exerts force on the ladder, but it's an equal and opposite force that the ladder exerts on the man, so on the net system, it's nothing. Therefore, and we're also told that the mass of the ladder is 0, so it's got no momentum, no matter what its velocity is. So basically, that will imply, so we've got, let's say, mass of the man times his velocity horizontally plus the mass of the ladder, which is 0, plus the v of the ladder horizontally is 0 if they're starting off at rest. Well, that's 0. So basically the horizontal component of the man is always going to be 0. So he's not going to go anywhere. So all that will happen, next diagram, is when he's got to the top, we could draw it on the same one, horizontally he's not gone anywhere at all, and the ladder is gone like that. So actually that would be a good diagram to put on the question sheet, is just to draw it again here and show that the man's gone up here. all he's doing is he's climbing, he's just pulling the ladder towards him.